Hello everyone. I welcome you all for this lecture in Internet Layer Protocols, which comes under the subject routing and switching. Now let us move on to this lecture. So introduction to internet layer protocols. So the protocol used in internet layer, it is used to handle the logical addressing in the network space. At the same time, it also helps in routing of the data across the network. So it always helps in the end-to-end communications of the network, and it is comes under the layer 3 of the OSI model, which is above the network access layer and below the transport layer. The key protocols used in this internet layer protocols are IP. So it is comes under in two forms. We all know that IP4 and IPv6. Then comes ICMP, then IGMP, and next is the ARP. So what this internet protocol ensures is that it ensures that all the data packets reach their destination across diverse network. It may use different routing paths. It makes sure that all routers which is sent by the sender is received by the receiver. The first protocol we are going to discuss is about the internet protocol, which is the core protocol for addressing and routing packets. So normally it comes in two versions, IPv4 and IPv6. So IPv4 is a 32-bit address space, and IPv6 is 128 address space. IPv4 uses binary, and that is the decimal formats, whereas IPv6 uses hexadecimal format. The key features of this protocol is both connectionless and stateless. It also uses the IP address for the source and destination identification using the routing tables. So what it actually does is it moves or it takes packet from the source to the destined destination based upon the source and destination addresses. It also helps in routing the devices between the source and destination. It may take an selective path, or it may resolve it dynamically, or it may use it statically. So that depends upon the environment. For example, if we are moving from one system to another system, both systems will be having IP addresses. So there will be sender will be having an IP address, and a receiver will be having an IP address. So this internet protocol helps to move these data packets from one IP address to destination IP address, whereas it results in moving data from source to destination. So here the IPv6 version comes is a successor of IPv4, which is an exact expanded address space. It uses 22-bit address, as I told you, and it supports 340 undecillion addresses. So it helps in simplified header and effective routing. So this avoids NAT, network address translator, whereas IPv4 uses NAT, and it also helps in identifying the systems which is comes under the internet of things network, and it also supports mobile devices, whereas IPv4 is a bit lag in all these things is. And the adoption of these IP addresses is increasingly it is used in globally, and people are migrating from IPv4 to IPv6. So next comes the Internet Control Message Protocol. So this protocol is used for error reporting and diagnosis of the network. It operates along the single IP. It is not using any specific port. It also how this works is it is uses by echo request, reply, and destination unreachable. So these are all the three messages which is used by the system to report if there is any problem occurs when the network is diagnosed. So whenever the networks is diagnosed with some problem, so we have to troubleshoot and make sure that the network connectivity is properly established. So normally we might use ping commands to check whether our network is connected with the internet with the help of echo request and echo reply. And this security vulnerabilities are most oftenly it is used by the hackers, so that we use this protocol ensures that our network is safe and it is being properly used. Next comes the Internet Group Management Protocol. So it is used whenever we are managing the IP addresses with multicast group memberships. It primarily uses IPv4, and it uses IPv6 uses MLD, and it also supports dynamic joining and leaving of the multicast groups. It comes in three versions: version 1, 2, and version 3. So all these versions having additional functionalities. So whenever we are using multicast delivery, this protocol is widely used so that it enables efficient and a very fast multicast delivery system. It is used especially in streaming media, that is a live telecast of any sports program which is which is consumed by multiple or even in lakhs and crores of subscribers. So for example, you can take a video joining and multicast group for video streaming, like any live telecast we can use this IGMP. Next comes the address resolution protocol. So this protocol is used for mapping IP address to the MAC address. So it operates in LAN, and it also uses in IRP mapping. So when it is used by sending ARP request and receiving the reply, and whenever we are using this ARP request, that is the address protocol. Address resolution protocol request is sent and it is properly manipulated and the address is resolved, then it is mapped along with the MAC addresses. So here IPv6 and IPv4 is widely used. So IPv4 has a lot of limitations, whereas IPv6 it accommodates a lot of addresses. The ICMP acts as a diagnostic tool. IGMP acts as a multicast management group. ARP makes sure that the connection is properly established. So here all these protocols together ensures a safe packet delivery in a network operations. I think we come to this end of this lesson, this lecture. We'll meet in the next lecture. Thank you.